it will create a cluster. And in second step, it will choose two closest clusters and make them one cluster. And like that, it will repeat this step 2 until the whole cluster is formed. So now the question is how to find the distance between the clusters. So as we all know, to calculate the distance, there are two metrics which are used. One is Euclidean and another is Manhattan distance. So there are several types of linkages. So I am going to talk about two linkages in this talk, which is one is single linkage and another is complete linkage. So in case of single linkage, it measures the distance between the closest point of two clusters. So from this picture, you can see that there are two clusters R and S, and it will take this two closest distance to create the linkage. And in case of complete linkage, it will do the opposite. So it will take the furthest points to form the clusters. So you can see from this picture. Now, what is dendrogram? So a dendrogram is a diagram that shows the hierarchical relationships between the objects. So you can see that there are several points are scattered A, B, C, D, E, F, and right hand side picture is called dendrogram. So you can think of in x-axis that there are the objects or clusters, and in y-axis this is the distance between the object and cluster. So you can see from this left hand side picture that the distance between E and F is the nearest. That is why the height of E and F in this dendrogram picture is the lowest. And next is the AB. So AB height is the greater than EF. So like that. So x-axis are the objects or clusters, and in y-axis it is the similarity between the objects or clusters. So so which I have written here. So a dendrogram is a diagram that shows the hierarchical relationship between the objects. So first you have to focus on the height at which any two objects are joined together. So for example, which I have already discussed, E and F are most similar. So height of this link that joins them together is the smallest, and the next two similar objects are A and B, and so on. And the height of the dendrogram indicates the order in which the clusters were joined. And also, it is important to note that dendrogram cannot tell you how many clusters you should have. So there are two types of hierarchical clustering. One is agglomerative and another is divisive. So if you do the in bottom up approach from bottom to top, then it is called agglomerative. And if you take top to bottom, means if you take first this whole cluster and then you just split it into two clusters and like that, so it will be called as divisive clustering. So now how to implement this is using scikit-learn. So in scikit-learn there is a module called agglomerative clusterings which takes different parameters, and the most important ones are n clusters, affinity, and the linkage. So n clusters are the number of clusters you want to use, and by default it is 2. So it means if you don't write anything, it will take the number of clusters as 2. And affinity means the metric used to compute the distance or the linkage. So here you can write Euclidean or L2 norm, or Manhattan or L1 norm, or cosine distance. And linkage, there are four types of linkage. One is single, complete, average, and odd. So by default, if you don't write anything, it will take odd as a linkage. So in this tutorial, I will show only single and complete linkage. And to plot the dendrogram, there is a module in scipy. And what is the difference between scipy and scikit-learn? So if you see from this picture that scikit-learn is built on top of scipy. So in this bottom layer there is a Python, and this second that is scipy, and then scikit-learn. So scikit-learn is built on top of scipy. So in scipy also there are several um, modules like that. in clustering. So that is a module called hierarchy.linkage. So if you want to plot dendrogram, you can use it. So it will take several parameters. So first one is y means the data set or the features you want to use, and then is method or single or complete like that, which is same as this linkage here. And third one is metric, so Euclidean or Manhattan like that. So first of all, I want to show a simple example how this clustering works in scikit-learn. So here the objective is to form a large cluster using combination of small clusters or data points, and to show the dendrograms of the clusters are used to actually split the clusters into multiple clusters. So for example, there are several points like that, 5, 3, 10, 15, 15, 12 like points are. So you can plot it using scatter plot like that. So what I have done is, you have just import those libraries matplotlib, pandas and numpy. Then I have created these points in numpy.array, and then I have called this agglomerative clustering from scikit-learn, and then you just write cluster agglomerative clustering, number of clusters equal to 2, affinity Euclidean and linkage single. So it will see that number of clusters are 2, that is why 1 and 0. So labels are 1 and 0, and if you plot it, you will see these points 5, 3, 10, 15 like that. So it is 5, 3, 10, 15 like that. This is a scatter plot. So if you want to plot in dendrogram, so you have to call this scipy.cluster.hierarchy, and then you can plot the dendrogram here. So you can see that dend equal to shc dot dendrogram. So shc here, and then linkage x is the data points which are taken here numpy array, and then method is single or complete, and then metric I have used is Euclidean. So as I told, x-axis denotes the objects or clusters, and y-axis denotes the distance or similarity or dissimilarity between the objects. So here the points are 5, 3, 10, 15 like that. So in x-axis you can see that there is 4, 0, 3, 1, 2, and it is denoting the first point as 0, 1. So here you can see that there are several points. So you can number it like 0, 1, 2, 3, 4, 5, 6 like that. So 0 to 9 points are here. And if you see that, so 1 and 2 is the minimum height. So you can see the point is 10, 15 and 15, 12. So distance between 2 points are minimum. That is why the height of this dendrogram is minimum. And after forming this cluster, it will take the another cluster as 3. So 3 means the point number 3, 24, 10. And like that, it is creating the whole dendrogram picture. So here you can see that there are two clusters. One is denoted by green and another is red. And similarly, if you want to use complete linkage, you just change this parameter as linkage equal to complete. So you can also check for another two linkage, which is called average and odd. So you can change here. So if you write linkage equal to complete, you will see that it will show this type of dendrogram. And here there is a difference. So you can see the difference here. The difference, as I have told, is for single linkage it will take the nearest points, and for complete linkage it will take the maximum distance. So now I will come to a real world example. So here the example is to cluster customers into different groups based on their shopping trends. So I believe we all use the e-commerce websites like Amazon, Flipkart. So there are several features of a customer of a order user. So like customer ID, gender, age, annual income, spending score like that. That is given to you, and you have to determine which to class which are the customers are the same taste or same trends, so that you can show them different same type of deal, ad or offer um, in e-commerce websites. So they here the dataset called as shopping data.csv. So if you plot this, the shape is 200 into 5. So it means number of features is 5 and 200 rows. And if you plot first 10 features, you will see that like that. So there are customer ID, gender, age, annual income, it is in $1,000, so $15,000 like that. And spending score, how much amount he or she is spending on this website, like that. So for that, I have taken only these two features, annual income and spending score, to cluster the customers. So you can see that data equal to customer underscore data I look 3:5. 3:5 means third column, and 5, and 5 means 5 minus 1 to up to 4, 3 to 4. So 3 4 0 1 2 3 4. These two columns will be taken. So here if you plot, you will see that these two columns will be printed. And after that, if you run this single linkage, which I have already discussed, so here you have to first import scipy.cluster.hierarchy as HSC, and then this is the figure size, the whole figure size. It is the width and 10 is the height. Then the title is customer dendrograms, and then you just use this data and single linkage and distance is Euclidean. So you will find this type of dendrogram images. So what it means is, in x-axis it is saying the number of customers. Each customers will be represented in this x-axis. In y-axis is how similar are those customers are, means how the taste or trends of the customers are same. So you can see from this picture, it is very um, intuitive, so which are the customers are same taste or same trends. So like that, if you want to plot in scatter plot, you can plot it. So to plot scatter plot, it is straightforward. You just call from scikit-learn.cluster import agglomerative clustering, and then n cluster equal to 5 I have taken, affinity Euclidean, and linkage is single. So these are the predicted clusters name, and then it is creating this scatter plot. And if you want to use the complete linkage, you just change this parameter as method equal to complete, and rest is the same. So you will see this type of image, and you can see the difference here. So difference is, this single linkage tends to add 1 point at a time to the cluster. That is why it is creating more dense or long strange clusters. You can see that these are compact. But in case of complete linkage, so complete linkage distance tends to create compact clusters of cluster. That is why it looks like that. So like similarly, you can just plot, if you want to choose 5 clusters, so you can plot in scatter plot like that. So to plot it, just data is to 0 1, it means first feature is the customer income, and second one is the number of amount spent in this website, and then it is the labels and cmap equal to rainbow. So you can see that 5 clusters are there. But here are some problems are there. So if you use this type of hierarchical clustering like agglomerative clustering or divisive clustering, the time complexity is very high. So in case of this type of clustering, if you use heap data structure, the time complexity will be n square log n, because to calculate the distance between 2 points, it will take log n, and for n data points. So the n log n for the calculate the minimum distance and put it into the heap data structure, it is n log n, and n is the number of data points, that is why n square log n. So if the number of data points or number of clusters or number of customers are very high, which is very usual in real world, so this time will be very high. This is the first disadvantage. And second one is, no objective function is directly minimized here. So if you recall, we have a loss function for k-means plus plus, which is intra-cluster distance, but in this case there are no loss function. And third is, sometimes it is difficult to identify the correct number of clusters by the dendrogram. So if you see in this case that these 5 or 2, these clusters are just I have taken arbitrarily, there is no logic behind that. But in case of k-means plus plus, we have used this elbow method or knee method, which are used to determine the best value of k. But in this case, we didn't do this. So this is the also, and dendrogram also can't tell you the number of clusters. So it is very I think bad idea, and it is also sensitive to noise and outliers. That is why nowadays this technique is used, which is called latent class analysis, so which is a probabilistic approach. So to know more about that, you can go through this paper or article, which is named as using latent class analysis versus k-means or hierarchical clustering to understand museum visitors, and those are the authors. So you can go through that if you want to learn it. So I think that's it from my side. So if you